Hi students, this is Dr. Maya Dunne. I thought it's a good idea to have the video about this scientific notation and significant figures. It's very important in chemistry. You represent your answer, the numbers in the scientific notation. Scientific notation has two things. Like whenever you have the number, we call coefficient and power of 10. Example, if you look at this particular number, look at 1.5 into 10 to the power 2. 1.5 is the coefficient. 10 to the power 2 is power of 10. Any number you can write in a scientific notation. In scientific notation, coefficient always less than 10. Even 0.5 you can write as this in a scientific notation. So here we take the 150. So you take the number, okay, always when there's a number, there's a imaginary decimal place. So you take, how do you make 150 less than 10? You take the decimal place, you put it here. It's 15, still higher than 10, right? So you take one more place. So then 1.5, you'd move decimal place 2 times, 10 to the power 2. Always keep in mind the 10 to the power become a positive. This is important. 10 to the power become positive if the number is bigger than 1. 150 is bigger than 1, higher than 1. Always 10 to the power positive. If a number is smaller than 1, let's take 0.5 as an example, your 10 to the power become negative 1. So here, you want to write it as like 5 into 10. So you take decimal place here, like that, moved here. So it's going to be 5 into 10 to the power negative because you move backwards. That's the basic idea. Any number you can write it in a scientific notation. If the number is bigger than 1, your 10 to the power become positive. Number is less than 1, 10 to the power is negative. So these are bigger numbers. Of course, you know their 10 to the powers are bigger, right? Positive. So you can write, okay, 2 point. So you have the imaginary 10 to the power here. 1, 2, 3, 4, 5, 6, 7, 8. 2.77 into 10 to the power 8. Let's check the answer. Yes, that is correct. So let's go this one. You look at B. You have the imaginary decimal here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 9.38. You write all the numbers. You can just drop it. You can write 9.38 into 10 to the power 10. Something like that. You write. Okay. So then let's look at some smaller numbers. Okay. These. So these, by looking at the number, you know you get negative decimal. Negative 10 to the power. Why? Because your number is less than 1. When the number is less than 1, definitely your 10 to the power would be negative. So let's see how many negatives you move. You already see the decimal point. 1, 2, 3, 4, 5, 6, 7, 8. Then when you do 3.38 into 10 to the power negative 8. You look at this one. 1, 2, 3, 4, 5. 2.1 into 10 to the power negative 5. It goes like that. Okay. So that's the scientific notation. And then sigfix. So that's the end of the scientific notation. I'm moving to the sigfix. Sigfix, in the exam I'm asking, identify how many sigfix in this number. Okay, round this number to 3 sigfix, something like that. So the significant figures are another important aspect. Sigfix, there are rules for assigning significant numbers. Any number that is not 0 is a significant number. Any number you have it in, it's a significant number. So example, 18.99911. No zeros, all numbers are significant. You have 5 sigfix, 4.1, 2 sigfix, like that. Next one, zeros located between non-zero digits. Like this 0 is non-zero, right? Between. So this 0 is also significant because it's between non-zero digits. Because of that, this number, even though it has a 0, that 0 located between the non-zero digits. So 3 sigfix. This one, 5 sigfix. 5 sig figs. If it is different, the story is different if the zeros are not in between non-zero digits. Okay, look at this one. Zeros to the left of the first non-zero digits. Okay, so this is the what is that? This is the decimal point. Where's my cursor? Where's my cursor? Okay, let's read the rule. Zeros to the left of the first non-zero digit are not significant. This is the first non-zero digit. This is the first non-zero digit. This is the first non-zero digit. This rule is very important. 0.11, even though it has 3 numbers, this 0 is insignificant. So 2. These ones you don't take it. Why? Because it's a left. So you don't take it. But this story is different if you have let me take a pencil and let me see whether I can write. Okay, pen, that's good. So I have 0.000060. I'm asking, okay, how many sig figs? This one is 1, but this one is 2. Why? Because it's after. So I hope you get it. So then the fourth rule, zeros to the right of the last non-zero digit are significant. If the numbers contain a decimal point, yes, this number contains a decimal point. So this is a 3 sig figs, 1, 2, 3, 4 sig figs. This one, 1, 2, 3, 4, 5. Because it's after, you can, but if it's before, it's insignificant. Okay. And then fifth rule, zeros to the right of the last non-zero digit in a number that does not contain a decimal point may or may not be significant depending on the circumstances. What are these circumstances? The number 150 may have 2 or 3 sig figs. Without additional information, it is not possible to know for sure. To avoid ambiguity in such case, it's best to express the number in a scientific notation. If you can't, so this is what it is. If you can identify how many sig figs in this number, you take the number, you write it in scientific notation. Coefficient always significant. So when you write in the scientific notation 150, 1.5 into 10 to the power 2, 1.5 is this 2 sig figs. These two. If the intended number is significant figure 3, meaning that 0 is significant, number should be written like this way. Okay. So determine the number of sig figs, 3, 4 sig figs, because, and then this one, 3 sig figs, because you don't take this as a significant number. What about this? How many sig figs? I would say 4, because 1, 2, 3, 4. 50, I would go with 1 sig fig, because there's no decimal point. This one, 4 sig figs. So let's look at the answer. So 3 sig figs. This is contain 3 zeros are significant right to the decimal point. We would need more information, 1 or 2, so it's ambiguous. You can write ambiguous, that's fine. This is 4. So then there is another thing. One more thing before I wrap up. Addition. When you how do you express the sig fig in addition and subtraction? The rule is in addition and subtraction, you write the answer cannot have more digits after decimal point than the original number with the smallest number. So you add these two numbers. This number has only 2, so you can have to express it. Even though your answer has 3, you have to cut down here, you have to round off the number. And then the rounding also important, and then multiplication and division is another rule. You multiply this, there's no equal, okay, the 1.4 into 8.011. You multiply and get the number as 11 point is long number, but you have to give the answer to the least number of number with the least number of sig figs. So this has 2, this has 4, so you have to give the answer to 2 sig figs. So these are the rules of scientific notation and sig figs. I hope this video is helpful for you. Thank you.